Welcome back to part 2 of Module 11, Lesson 3, where we're continuing our study in generating multiple samples. We're now on example number 1 that has a dot plot that shows the means of 24 random samples of 20 runners. Let's read that again. The dot plot shows the means, that's going to be averages, of 24 random samples of 20 runners. So what they have is 20 runners, and off of each one of those runners, they took 24 samples. Okay, you with me? The 24 is kind of superfluous to us. They have averaged that 24 samples of each of the runners, and that is what's going on here in the chart. All right, of 20 runners across the local high schools for a 1-mile race. Each dot represents the mean or average of one random sample. What is the race time for the best estimate of the population mean? Find and intercept the variability of the distribution. Let's see what they want us to do next here. So the sample means seem to pile up somewhere between 6 and 7. Remember, means mean average. So the sample averages are piling up somewhere between 6 and 7. That's where most of them are going to land at. And you could also say that would be probably about 6.5 minutes as well. Now, if you found the mean distribution of all of these data points, the average distribution of all the data points, that means you're adding each one up, and you see they have the 3 times 5.5 because there's 3 of them. They have 5 times 6 because there's 5 6s here, and so on. So you added them up, and then you divided that by the 24 data points. I guess I was wrong about that information. And when you do that, you end up getting about 6.7 or 6.6 repeating, which rounds to 6.7. So the mean of the distribution is going to be about 6.7, which would be about right here on our chart. So we're going to scroll down and we're going to ask ourselves the question, what does this actually mean? What does 6.7 mean? It says the mean or the average of the distribution is about 6.7 minutes, which is near where the samples seem to pile up. This means that the mean or the average of the population is going to be likely close to 6.7. Now that we have found the mean of the entire sample, it's time for us to find the mean, what's that term, mean something deviation. Hold on. The A is absolute, mean absolute deviation. So it says to find the mean absolute deviation, find the mean distance each data point is from the mean of 6.7. Remember that the distance is always going to be positive. So what you had to do is take the 6.7 and find out how far each one of these points were from 6.7. Fortunately, they did that for us. You can see it all right here. When they found all those pieces, they divided by the 24 data points, and they found that the mean absolute deviation was a mere 0.8. That's a pretty small data value. You with me so far? So the average of all these pieces here is that they're only going to be 0.8 of a minute away from 6.7 minutes. Scrolling on over here, the mean absolute deviation is 0.8 minutes. It means the average distance from, that's what I just told you right there. So, what do you think? Do you think there's going to be a high, low, or no variability going on in this? I'm thinking it's going to be pretty low. There is variability because you have things scattered throughout the whole chart, but the majority of them are less than 1 minute away from that mean. So my thought is that there's going to be a low variability going on. Let's see what they said from here. Nope, they didn't say anything from here. They just wanted to ask that question. Okay. Now, rather than dump extra example 1 on you, we're going to do it together as well. It says the dot plot shows the means or averages of 15 random samples of 20 students. So they took, let's count up how many we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So they had 20 students total, and of those 20 students, 15 of them got sampled. You with me? Now, it says, and the number of social media accounts they have. Each dot represents the mean or the average of one random sample rounded to the nearest half. What number of social media accounts is going to be the best estimate of the population? Find and interpret the variability of the distribution here. A says find the best estimate for the population mean. Which number best represents the mean of the social media accounts? And they have a bunch of stuff there for us to choose from. That means we're going to need to do some math. The first thing we've got is we need to figure out what each of those numbers are going to be. So I'm going to take an average amount, which means I have, oops, hold on. There we go. I think I got it all fixed now. There's one, get my pen going. I have 1 plus 2 times 1.5. Oh, that's a 2, not a 5. Plus, there's 3 times 2. Plus, you have 4 times 2.5. Plus, you have 3 times 3. And plus you have 2 times 2.5, and all those things combined, that's going to end up being divided by the 15 points. So let's take our calculator and figure this out. I'm not going to make you watch all of that math. Okay, I added them all up and got a total of 36. I divided that 36 by the 15 data points and got a mean or average of the data points, which is going to be 2.4. Now, if I jump back over to my textbook, what do I see that 2.4 is closest to? Well, 2.4 is going to be closest to 2.5, so we're going to check that answer. That checks, and now it says find and interpret the variability of the distribution. The mean absolute deviation, ooh, now we got to get that, and that's not going to be a lot of fun. Now, since the textbook said they wanted to use 2.5 as a mean, that's what we're going to do, and that'll actually help us to make our math easier. We're going to call that the mean. So let's start picking them up. 2 is going to be 1.5 from the mean, plus 1.5 is going to be 2 from the mean, and there's 2 of those, plus 2 is going to be 0.5 from the mean, there's 3 of those, 0.5 plus 0.5 plus 0.5. And next I've got 4 of them that are 0 from the mean, which we can put in there if you want. 1, 2, 3, 4. And now on this side I have got 3 data values that are 0.5 from the mean. So that's going to be 0.5 plus 0.5 plus 0.5. And finally I have 2 more data values that are 1 whole from the mean. Plus 1 and plus 1. Let's average that by dividing it by 15. Alright, that gave me a total of 10.5, which I'm going to divide that by 15, divided by 15, and that's going to give me a mean absolute deviation of about 0.7. Now let's jump back over to our textbook and plug that in. We have a mean absolute deviation of 0.7 on the social media accounts. That means that the average distance the data is from the mean is going to be 0.7. The distribution has say a relatively low variability. That's not a lot of variability, and the estimate of 2.5 on the social media accounts as a population mean is let's see, likely far off from the true population, equal to, I say not far at all from the true population. We're going to check that. These two ended up being wrong, and I can only guess that they gave those wrong because they calculated off of the 2.4, which was a true mean, instead of the 2.5 that they tricked us out with. I'm not going to go back and redo that and make y'all look at all that again. We're just going to acknowledge the fact that for some reason we actually calculated the mean as being 2.4. They wanted us to round it to 2.5, and then they went ahead and used 2.4 to calculate it with. So just understand all that, and yeah, we're good. That's going to be it for today's lesson. There's a lot of work involved here. I understand that. Do the best you can. We're going to look at it in class again tomorrow, and I look forward to seeing what you come up with for questions. I'm expecting some questions on this, guys.